get started. So I want to make a WEBGL sketch. It's going to be like a 3D scene, and I'll bump up the canvas size here a little bit. All right, and then we're going to use a camera. So before that, I'm just going to use OrbitControl, which is like a built-in way to drag and move around in the scene. So I'll just draw a line from 0, 0 to 100, 0 for the x-axis, and a line from 0, 0 to 0, 100 for the y-axis. And we'll make the x-axis red, and we'll make the y-axis green. And now you can see we have an x and a y-axis here. And with the orbit controls are giving me the ability to like click and drag, or I can right click to pan around, and you can mouse wheel to zoom. There's also a function called camera. So if I were to do something like this, I use push pop to get a new drawing context, translate 100, 0, and then draw a sphere with a radius of 10, and we'll say fill, make it white. Oops. Make it white, and I'm also going to turn on the lights. Okay. Oh, no stroke. I zoomed in and then I saw that it was all the lines there. Okay, nice. So now we have this sphere, and I did that so I can show you if I were to call camera 0, 0, 0, put it at the origin. So the first 3 arguments are the position of the camera, and then the next 3 arguments are the look at point. We can think of the 3 together as like the look at vector. It's like the direction that it's looking. So, and then the last one is the up vector. 0, negative 1, 0. So now I'm looking directly at the sphere. If I call that function camera. So we're going to use this function to make a first-person controller. So I'm going to create a camera object, say let cam equal, we'll give it an x, a y, and a z for the position. We'll give it a theta and a phi, which are the angles for the look left and right and up and down. And we're going to use these like how you use like spherical coordinates, sort of. So along like the latitude and the azimuth or something. So, and then we're going to specify a look at point. So this property is going to be an object itself, and we're going to give it an x, y, and z value. So this look at point is what we're going to use. So we're going to, when we call this function, we're actually going to call, instead of 0, 0, 0, we'll call cam.x, cam.y, and cam.z. So that's the position. And then look at point, I know I said before that it was like a vector, but it's actually not quite right. It is the actual point. So you want to look at that point. So no matter where the camera is, and then the point in space that the camera is looking at. Hope that makes sense. Okay, so cam dot look at dot y and cam dot look at dot z. Forgot a comma. No, forgetting commas. Okay, perfect. And we're going to keep the camera always fixed with a up direction in the negative y. As you can see, the y direction is down, so negative y, the up direction is pointing up. And this is a vector. All right. Now, we want to do, I'm going to do some mouse controls. So we'll say mouse previous, and then we'll say x will be mouse x, and y will be mouse y. And we're going to use that so that we can move the mouse to get the camera to control the camera, get the camera to move. So in our draw function, draw gets called every frame, so we can say mouse. Oh, actually, we're going to update cam.theta. So cam.theta plus equals, we'll say mouse x minus mouse previous x. So when you move the mouse, it will update the left and right, and that's with the x value of the mouse. And then we want to move the mouse up and down to control this phi angle. So plus equals mouse y minus mouse previous dot y divided by 100, because these values are going to be pretty big, and for theta and phi in radians, we want to keep those pretty small. So then here we can, let's add a rotate. So we will rotate about the y-axis, by cam.theta, and then rotate about the z-axis by cam.phi. Oh, and I forgot to update mouse previous dot x equals mouse x, and mouse previous dot y equals mouse y. So you got to update that every frame. Okay, so now you can see if I move left, right, and then down, up, the ball moves, and that ball is going to be our look at point. Okay, so now we have this, but we need a look at point. And there's no way in P5.js to just say like where we are now, unfortunately, or maybe there is, but I don't know how to do it. So what I'm going to do is use my own custom matrices instead of using these. So to do that, we're going to use these, and we're going to use Math.js. So I'm going to get the CDN for Math.js. Okay, so now we should have an object in our JavaScript called math, and then I should be able to say function rz of some angle, and it will return, math.matrix. And this is an array, and we need the columns here. So it'll be cosine, sine, negative sine, sine. So cosine of theta, sine of theta, 0. And then negative sine of theta, cosine of theta, 0. And then the last column is just 0, 0, 1. So that's our z, and then our y is cosine, negative sine, sine, cosine, and a 1. So we'll do something similar to this. I'm running out of time. Okay, so our y will be cosine, boom, negative sine. So 0. And then negative sine, and then same idea here, 0, and sine, cosine. So sine, cosine, and then the 1 goes here, and then this is 0, and then I actually need to switch these. So this one goes in the middle. Good. Okay, so then I should be able to say, we'll say like let x equal 100, 0, 0, and then we can say let r, which is going to be our rotation matrix, equal math dot multiply No, I'm out of time. Dismiss that. Let's keep going. Multiply. We're going to multiply. So we're doing matrix transformations. So you want to do them in the reverse order. So we're actually going to do R, because normally we're going to rotate by Y, right? Want to rotate around the Y-axis and then around the Z-axis, and the Z-axis here is pointing out of the screen towards us. So we'll rotate RY of cam.theta, multiplying that by RZ cam.phi. Okay, and then we say cam.lookat, and then hang on. So now I'll say x equals math.multiply x comma r. Okay. And if it didn't like that, it would have said mismatched dimensions, so we should be all set here. And then I'm going to say cam.lookat equals lookat equals x is going to be x dot data 0 of 0. So x, y, and then z. X, y, z, x, y. Oh. So x is just what I'm calling this, and it's because it's looking down the x-axis, I just called it x. And then so we need to actually change these to 1 and 2, pretty sure. All right, so now instead of this, let's test out what we have here. So we'll translate cam.lookat.x, cam.lookat.y, cam.lookat.z. Okay. Problem with the scope. Let's see what we have here. Console.log x. Yep, okay. Data. Console.log cam.lookat. Oh, undefined. Huh, okay. So I need to, I had this wrong the way this worked. Okay, now we should be good. For some reason I thought data, x dot underscore data was returning an array containing an array, but I think that was because I made this a matrix last time, and now I'm just leaving it as an array. All right. How are we doing here? So this looks like it's not quite working how we want it to. I'm just going to try switching these because maybe I had the order incorrect. This seems a lot better. Yeah, so it's looking up and down, left and right, up and down. And now to test this, we can do this. Okay, good. So it's staying in view. And to see where we're actually looking, I'm going to make a big sphere, sphere 100, and we'll say no fill. Put this in a push pop just so that we don't get these fill effects spilling over. All right, yeah, no fill and stroke 0, make it black. Sweet. Okay, so now we're looking right, left, up, down. Now the last thing to do is give some movement controls. So let's do that. So let's say 87 is the up key for W and 83 will be down. So we'll say if key is pressed and key code is 87, then we'll do our up movement. And for that, we're going to say cam.x plus equals, we'll say 2 times the cosine of cam.theta, because cam.theta is our left, right, look around one. And then cam.z, remember z is actually not up, it's the other, because negative y is up. We'll do 2 times the sine of cam.theta. It's looking a little weird. I think this is actually supposed to be negative. And the reason for that is because in P5.js, it's actually not a right-handed coordinate system. It's a left-handed coordinate system. So sometimes if you, like these rotation matrices, I'm pretty sure these are for a right-hand coordinate system. So sometimes things just need to be flipped around, and if you don't fully if you don't want to like switch everything to a left-handed coordinate system. So this works, but we're noticing like the ball should be right in front of our face, that being our look at point, but it's not. So that's why we're also getting some weird behavior in here. Like I should not be moving that way. I should always be moving, towards the ball when I'm hitting the forward key. I should always be moving in the direction that I'm looking. And the reason is our look at point is not a vector, it's a point. So this needs cam.x plus this vector, cam.y and cam.z as well. So that's saying our look at vector is being added to our look at our current position, which is the camera. And then I think we should be good. Nice. Okay, so now we are moving, which is great. And then I also want to be able to move backwards when I hit the S key. I think that was 83. And then I'll just flip the signs here. Make this plus, make this minus. Nice. And the last thing is the strafing left and right. So 68 and 65. 68, 65. And all we have to do is add pi divided by 2, because we want it to always be 90 degrees from the forward, backward, left, right motion. So let's see how this works. Perfect. So now we go forward, backwards, left, right. You can look around, move in that direction, look up and down. So yeah, this took twice as long as I was going for, but I hope you enjoyed the video, and thanks for watching.